Okay, what we're going to have a look at today is delta star arrangement, and this is what you're likely to see in a substation situation in your network, where you have a last transformer in the network comes in, and the winding on the delta side is shaped like a delta Greek letter symbol, which is why it's called delta, and only have L1, L2, say L3. We have our core of the transformer, and on the secondary side the windings are arranged what we call a star. Some call it a Y, like that, and that goes off to your customers. And we have L1, L2 and L3. Now normally the last transformer in your network has an 11 kilovolts on the input primary side. So if you measured the voltage between any two phases here, you'd get 11 kV. And on the secondary side here we have three phases. Now the majority of loads on the network are what we call unbalanced, and to balance the system properly we need what we call a neutral. So we have a fourth wire here called a neutral, and you'll remember that the neutral at this, what we call the star point, this is the star point, this neutral here is connected to earth, and all the metalwork of the transformer is also connected to this point as well. And this is why you can get an electric shock, because effectively if you touch a live part, electricity goes through you, goes through the earth and finds its way back to the star point here, and that's how you get an electric shock. Well, you might think, well, why do we earth it in the first place? Well, the thing is, there's two reasons for that. One is to provide the neutral, and the second reason is to effectively preempt a fault on the network. So it makes sure that the whole of all your customers are at the same potential with respect to earth. So that's the main reason it's done. Right, so if you measured, get a change of colour here, if you got a voltmeter here and measured the voltage between, say, any phase and neutral, you would get 230 volts. If you were to get a voltmeter and measure between, say, any two phases, so if we went between here and here, we would get 400 volts. So phase to phase equals 400 volts. Phase to neutral equals 230 volts. And because the neutral is at the same potential as the earth, it's connected to the same point, phase to earth will also be 230 volts as well. Okay. So that is what we see in the final part of your network. Now, with some overhead lines, some transformers would simply use two phases for the primary, and you might only get a single phase and a neutral point, or effectively an earthed point for your overhead lines. Well, we'll discuss that later when we talk about overhead lines. But as far as the cables are concerned, most of the cables that you will see in your city and towns buried under the ground will have 3 or 4 cores. Older cables will have 4 cores, so they will have 3 phases and a neutral, like that. So they're your 4 cores in the cable. The newer cables will simply have 3 cores and a shield over the a sheath which is effectively connected to earth. So there will be always 3 phases and another cable. So new cables will have just 4 cores, which will be the 3 phases plus a combined neutral and earth. Or the older cables will have 4 cores, effectively 3 phases, a neutral wire and an earth conductor as well. So that would be the 4. So you're likely to come across two types of cable in your urban network. Okay, so this video should help you with some of the questions in the cables task sheet. Okay, thanks very much, bye.